Okay, we have our period versus spring constant already graphed. If you need to know how to do that, please go back and see the previous video. And we put a curve fit and we chose that the power fit was the best option. And I want to show you how to take that power fit and write the equation for that. And so we've got y is equal to a times x to the b power. So remember that our y-axis is the period and our x-axis is the spring constant. A here is just a constant. It's a number. The power is what we really want to focus on. Notice it's a negative 0.48. And my math brain says negative. Well, that means inverse. So a negative power means it's going to be in the bottom of a fraction. I also know that 0.5 means square root. So a power that's a 0.5 means square root. And so I'm going to make some meaning to this function and say, I'm going to guess that the period is proportional to the inverse of the square root of the spring constant. I know that seems like a lot, but follow my logic. All right, so we're going to head back to our data practice, and we are going to write our equation. Now you need to graph yours here, right? And so we're going to write our equation, and we use the power equation y is equal to, let's see if I can get that to go away. There you go. Y is equal to, and we said a x to the b power. And those numbers, you can go back and look at that if you need to. Those numbers were, okay, so I'm going to say period is equal to 4 point, I'm rounding a little bit, 37 times the spring constant, k, because that's on my x-axis here, right, to the negative 0.48 power. Now, that negative 0.48 power, that doesn't make a ton of sense, right? Like, what is that? We talked about earlier how we think that that is most likely the square root, and the negative here tells us it's in the bottom. So I'm going to rewrite my equation as t is equal to 4.37, just kidding, 0.37 divided by the square root of k, the spring constant. Again, that negative here tells us that our that power here goes in the bottom or the denominator, and the 0.48 is a square root or a half, and so this is our final equation. In order to linearize data, we're essentially going to manipulate the original data so as to make it form a line. So we saw that the period was directly proportional to the inverse of the square root of the spring constant. So what we're going to do is we are actually going to, and I'm going to use this expression right here because it's a little bit easier to create in graphical analysis. So what I'm going to do is I'm going to take the spring constant to the negative 0.5 power, or also the inverse of the square root. So that's a decimal point there. That's a negative, and this is like a to the, right? And then over here is still going to be the period. So essentially what I'm going to do is I'm going to take all of these values right here, and we're going to take them to the negative 0.5 power. Okay, so this is a spring constant, again, to the negative 0.5 power. I'm going to go to graphical analysis. And to do that, I'm going to click on the spring constant because that's the variable I'm going to manipulate, and go to column options, or this little drippy dots here. And I'm going to add a calculated column. And I'm going to put in here in square root inverse of square root of spring constant. At this point, that unit isn't going to make a whole heap of sense. And then I'm going to go ahead and just insert the expression. And I'm going to use the exact same expression that we used when we put a curve fit in. So I'm going to use this power function right here. Now, you'll notice that power function, that parameter A is going to be the variable that's out in front. We don't need to worry about that. And then it's times the spring constant, and then to the power right here, we're going to go ahead and put in here that negative 0.5. And we're going to apply. So you'll see over here in the data table, I've added a column, and essentially what it's done is it's taken each one of these values and taken the inverse square root of that, or to the negative 0.5 power. And these are the numbers that you have. Now I'm going to come back over here to my graph. Notice it still is displaying period and spring constant. So I'm going to click down here on my spring constant, and I'm going to change it. And I'm going to change it to the inverse of the square root of the spring constant. Voila! Look what it does to the data. It literally linearizes it. Remember when we write a line, or we write the equation for the line, we would say the period is directly proportional to this independent variable here, which is the inverse of the square root of the spring constant. Are you following me here? Right? So either way you look at it, we have a period is directly proportional to the inverse of the square root of the spring constant. Or you could look at it this way. We'll go ahead and display the spring constant again and put that power fit back on. Again, we'll see that the period, y, is directly proportional, that's what the equal sign means, to some variable, to x, which is the spring constant, to the power. And that power, again, is the inverse square root, or the negative 0.5. All right, so I'm going to look back at our inverse of the square root data. And now, you guessed it, friends, I'm going to put a linear fit in here. So I'm going to go back here and apply a curve fit, and I'm going to apply a linear fit. Look at that slope. 4.465. So now I can write my equation of the line using my period and inverse of the square root of the spring constant. Okay, so we're going to use this y equals mx plus b format, and that y-intercept, the slope of 4.465. And we're going to write the equation using y equals mx plus b. We will go ahead and use that b value because it's there, and we'll eventually need to talk about that. Okay, so I'm going to head back to this. And my equation now is, we are going to use that regular format of y equals mx plus b. And when we graph the period by the spring constant to the negative 0.5 power, or the inverse square root, we ended up with a linear function. On my y-axis, again, is the period. The slope was 4.43. And we'll say spring constant to the negative 0.5 power. And we had some small, I think, y-intercept. I'm going to have to go back and look at that because I don't remember what that was. Oh, it's 4.47. Okay, so B is, we'll go 0.03. So this was 7, excuse me. So we'll put 7 in here. And this was 0.03. So again, if we look at this, our period is again directly proportional to the inverse of the square root of the spring constant. So These two methods yield exactly the same results as they should because the relationship between the variables is dictated by physics. The period is proportional to the inverse square root of the spring constant. All right, so either way you do it, you're going to yield that same equation. You're just manipulating that data in order to create a line over here so that it's easier for us to write an equation for. So one more time, remember to do that. You create that column. You first determine the relationship, create the column to do that relationship to either the independent or dependent variable. You then graph it, right? So you got to come down here and tell the computer what you want to graph. And then you'll be able to put a linear fit in and write the equation for that line. All right, best of luck to you, and I'll see you